We are in Chapter 4, Discrete Random Variables, Section 3, the binomial distribution. So we've got problem 7 here. So the random variable x is a binomial random variable with parameters shown. Use the tables in Chapter 12 to compute the probability indicated. So we looked at that the table has cumulative probability values for the binomial distribution. This first one, A, what I have showing here is n equals 10, n equals 10. No, that can't work. So I'm going to use P on this first one for 0.25. So that's changing what that typo there in the book is. So we'll look then for the probability that a random variable x is less than or equal to 6. So go and look in that table and the section for n equals 10 and looking at 0.25 for our p value. And as we look into the table, that's where we get the value of, let's see, 9965. So it's extremely likely that it's going to be less than or equal to 6. Okay, so now on our next one, for B, once again, n equals 10, probability 0.75, we're also looking at probability that x is going to be less than or equal to 6. So it's different here. The p-value is much higher. The likelihood of something happening is high. So the value of x, the likelihood of that will be higher, so the probability of it being lower is going to be a lower number. So when we look in the table, we see there that it is, let's see, 2241. So probability is 0.2241. Now we'll go to a different spot here on the table because we're looking at where now n is 15. And so the probability is looking at 0.75. So again, the probability that it's going to be low is going to be even lower, so this should be even a smaller number. So in this case, we look on the table under 15, it is 0.0042. If you look at the table. And here, the probability, here we're looking at n equals 15 and p of 0.75, the probability that the random variable is going to equal 12. So x equals 12. Well, this is a cumulative distribution, so we can look at the probability that x is less than or equal to 12, and then subtract off the probability that x is less than or equal to 11. So less than or equal to 12 minus less than or equal to 11. So this will subtract off everything from 11 down. That'll leave us only with the value for 12. So if you look at those in the table, we have 0.7639 minus 0.5387. We wind up with 0.2252. So the probability of it being exactly 12 is 0.2252. Okay, so let's look at our next one here. So the probability that for n of 15 and p of 0.666666 or 6 repeating, what's the probability that x is between or equal to 10 and 12? So here we have the probability that x is going to be less than or equal to 12. So that gets us the probability all the way up to and including 12. And we want to subtract off the probability below 10. Because we want to include 10, because this is less than or equal to 10. So if I were to subtract off a probability of x less than or equal to 10, I'd be subtracting off that 10 piece. I don't want to do that. So the trick here is that I have to look at probability that x is less than or equal to 9. So because 9 will leave 10 in the probability and take everything below it down. So there's the trick, which you have to watch out for on these when you're doing discrete probabilities, where you have discrete random variables, that you're subtracting off the right part when you have this range that you're looking at. So again, 12, we had that just a moment, I was going to say we had that a moment ago, but that was a different p-value. So here we have 9206 for this p-value, minus 0.3816, we get 0.5390. Okay, there we go.